problem 4.6 in the text deals with basic statistics. The problem states, for these following numbers, find the mean, the standard deviation, and the 90% confidence interval for the mean. The mean, or average, is the sum of the measured values divided by the number of measurements. For this data set, we sum each of the values in the numerator, divide by 5 the number of measurements, and we find that our mean is 108.64, which is equal to 108.6. Here we set aside the mean, 108.64. We keep that 4, the extra significant figure, for future calculations. However, if we stopped here and reported the mean, we would correctly report it as 108.6. The standard deviation is shown by this equation here, where xi is each individual measurement and n is the number of measurements. So we insert the first measurement, 116.0, we subtract it from the mean, 108.64, and we square that. We then add in the next measurement, 97.9, subtract 108.64, the mean, and square that. And the other three measurements, we complete our numerator. We then divide this by the number of measurements minus 1. And we take the square root, and we find that our standard deviation is 7.1 and rounds to 7. Note that there are two significant figures in the standard deviation calculated here. The number of significant figures in a standard deviation varies. However, the value is typically calculated using a spreadsheet or calculator without writing out each deviation, making it difficult to determine the correct number of significant figures. In addition, standard deviation can be considered analogous to uncertainty, which should be reported to one significant figure, with only a few exceptions not covered in this class. Therefore, we will always report standard deviation to one significant figure. We now also set aside the standard deviation, 7.1, with one extra significant figure to prevent rounding errors in future calculations. The confidence interval is shown by this equation, where t is the student's t for n-1 degrees of freedom from table 4.4 in the text, and n is the number of measurements. The confidence interval is equal to the mean, 108.64, plus or minus the student's t for 4 degrees of freedom, which is 2.132. This is then multiplied by the standard deviation, 7.1, and divided by the square root of 5, the number of measurements. Therefore, the confidence interval is 108.64 plus or minus 6.8. We then round this to 109 plus or minus 7. Since standard deviation is rounded to one significant figure, t times s divided by a square root of n, or the confidence interval, is also rounded to one significant figure. The mean is then rounded to the same place, the ones in this case.